All right, I think we're good to go. Good afternoon, everyone. Thanks for coming. It's good to see that many of you have survived the first night in Reykjavik. My name is Attila Szantner, and I'm a co-founder of a Swiss startup named MMOS. We are here with CCP Scarpia today to talk about the project that we started about a year ago. But before I start my slides, I wanted to make a quick survey. Give me a hands up if you're familiar with the term citizen science. Okay, not bad. And again, give me a hands up if you've actually participated in citizen science projects. Okay. Quite cool. So that's today's topic. And citizen science is when the general public is helping scientific research. Or as Wikipedia puts it, scientific research conducted either in part or in whole by amateur or non-professional scientists. It's definitely not a new thing. It's a relatively new term, but in old practice. Like you can look at these images. This is a scientific research topic which is heavily supported by citizen scientists and has been going on for decades now. But let's go to the online scene because that is more interesting for us at the moment. On the online scene, things get a bit easier because it's easier to distribute the problems, it's easier to gather the results. We have just because of the sheer numbers, we have the luxury of handing out the same problem to tens of users, so as to ensure the quality of the results. And probably those of you who have actually tried citizen science have met this project, which is the Galaxy Zoo, and it's a part of the Zooniverse platform, and that is the biggest platform for citizen science at the moment. They have something like 25 projects going on simultaneously, from astrophysics to zoology, from cancerous tissue sample analysis to plankton marking on photos. They have more than 1 million users, and they're producing quite amazing results. So if you haven't heard about it or you haven't tried it, I really encourage you to go and check it out because it's quite amazing. Here are some examples of what you're invited to do as a citizen scientist. For example, this is Moon Zoo. Here you're marking craters on the moon by marking their size, their shape, or you're invited to mark astronomical objects, or in this case, planktons on photos. But what's more interesting for you guys is what the hell does it have to do with Eve? Well, the story is that about a year ago, we came up with a crazy idea. And the crazy idea was, why don't we take these scientific research problems, transform them, and then inject them into major computer games as a seamless gaming experience. As a seamless gaming experience that they're completely integrated into game mechanics, into the game narrative, and of course visuals. And that we think is something huge. Just think about the enormous amount of time that we spend playing games. There is a very inspirational TED talk by the game designer Jay McGonigal. Maybe some of you have seen it, where she's talking about how games can be a tool for changing things in real life. And she says that together players played 5.93 million years with World of Warcraft. 5.93 million years, that's geological timescale. She's comparing it to human evolution. And we thought that if we can take just a small fraction of that time, then and transform it to something that helps science, that is huge, that is amazing. We're talking about tens of thousands of years. And we believe that that will change how science can rely on citizens or on gamers, and actually that will change how games are perceived. So the question is why citizen science is important. Probably you've heard the story of IBM's Watson, their AI machine, to basically destroy human beings at jeopardy. And one would think that a mighty entity like that, for it analyzing an image shouldn't be a big problem. Well, it turns out to be that sometimes that's not the case. Sometimes us humans, with our cognitive skills, can beat computers. For example, here is an image from, again, from Zooniverse. And for us, it's quite clear that what we see is a giraffe. For computers, may have some hard time to decide that. But even if you have a state-of-the-art machine learning algorithm, to make it work, you need a large and good quality data set, a training set. And to create training sets like that, citizen science is an invaluable resource. And also I brought this picture because this shows something that is really unique in human research, or the human eye, which is called serendipitous discovery. It's the lucky accident, it's the lucky coincidence. This image is from the Galaxy Zoo project, and here your task is to analyze or to classify galaxies by shape. One citizen scientist noted this green smudge below the galaxy that she was supposed to analyze. And actually she informed the researchers, and it turned out to be so interesting that it became a research topic by itself. And actually I think they moved the Hubble Space Telescope to get a better look at it. And in honor of the citizen scientist who found it, they named it Hannah's Warwarp. But you actually don't have to go that far. It just happened like a couple of months ago in New Eden, and that's Caroline Starr. It's really the same thing. So I think we can confidently say that citizen science is playing indeed a very, very important role in contemporary research. However, there are some shortcomings. One thing is that, of course, there are more problems than people who are willing to give away their free time to contribute to science. But what's interesting with this new setup, where we're connecting games with citizens or with science, is that we're not looking for some additional free time. You're already there. You're already solving problems in games. We just help you to solve problems in real life too, in the meantime. Then there is this tendency that many people go on these sites to Zooniverse, they try out this service, they make a couple of classifications, and they leave. The first graph with the squares show that every square is a user, and the size of the square is proportional to the number of classifications they've done. And you see that there are power users, and then these power users are making a really large amount of the work. There are statistics, and they say that about 80% of the work is done by 10% of the users. That's a bit dangerous because they're a single point of failure. So if you lose one of your power users, you might lose a significant percentage of your processing power. And also on the other graph, you see that these users' activities are really dependent on media coverage. Those spikes in the graph are articles in Time magazine. And again, if we're thinking about connecting games with science, that's going to change it, because with a clever game design, these things can be much more reliable, much more stable. So where our hypothesis is that this setup is going to answer all these problems that we face with citizen science as of today. So we thought that it's something interesting, something very important, and we started to work on the project. And right in the beginning, we knew that EVE Online would be a perfect partner for a project like this. And so my task was to learn EVE Online. So I started to play. Actually, I had an old account. And at that time, it was years ago. I didn't have really time. It was, the learning curve was quite steep, so I quit. And then I reopened my account. I got into my pod and I started to do things like this. Of course, I think it was a venture, actually. And then things like this. And you probably know that EVE Online has this perception of being a ruthless, hyper-capitalistic, really harsh world for the newcomers. On top of that, there's really a steep learning curve. But as I played, I really discovered a whole interesting new world opening up. And I found very, very altruistic sides of this whole phenomenon, which is EVE. For example, there are the training corps. I don't know if any Ouch members are here, maybe? No? Well, anyway, I can thank those guys to learn what is nullsec and what is gate camping, actually. So that was one thing. At that time, I was part of my work was to actually play with EVE Online, which was kind of fun. And then we started to contact the two worlds that we wanted to connect. And on one side, there was the scientific research groups, and on the other side, there was CCP. And it was just mind-blowing. It was amazing, the support and the enthusiasm that we've met with. So now we're here, and we're working on a prototype. We're working together with CCP and with the CADI of Reykjavik University. Actually, the two guys from Reykjavik University are here. They're going to show you the prototype. There is a roundtable talk after this one. And of course, we created a company in Switzerland, a startup, which is, I think, the name MMOS is probably in the top 10 worst named companies. But we believe that massively multiplayer online science describes it pretty well, this whole concept. So that is our story, and actually we split up this presentation with CCP Scarpia, so he gets to speak about the interesting stuff and the fun stuff. Actually interesting for you in the sense that how it's going to be implemented inside EVE. But before that, I want to show you some of the raw materials that we're working with, which I believe it's very, very interesting. Images like this. These images are actually microscopic images of immunofluorescently stained subcellular structures. They're science fiction by themselves, without any further ado. Or this one. These images actually all come from the Human Protein Atlas, which is a Swedish research group. Or this one. This is like small galaxies on fire. It's quite amazing. And I think you can imagine how it's really a perfect match with the EVE visuals, with the EVE atmosphere. There was a very interesting presentation in Vegas last year where CCP Seagull said that they want to include elements in the game which are not deterministic, which are unpredictable. And the reason for that was that if the game designers know what is the outcome of a feature, then you guys will know it in like 10 seconds. And we think that this material is really awesome for something, some feature like that. This is life. This is completely unpredictable. And then we have images like this. It's not as psychedelic as the ones before. It's rather like a beautiful old Japanese painting. It's actually a tissue sample, again from the Human Protein Atlas. And what's interesting with this one is we get almost the same type of images from the French network Biogen West, and that's just amazing if we can serve two different research groups with in one place. That's just amazing. And then we have stuff like this. This is a blood smear sample. We're working together with a professor in South Africa, and he's in malaria diagnosis. And I think it would be quite amazing if, while playing with Eve, you would have the chance to help fight malaria. And then we have a lot of other projects, like we have projects in exoplanet research. We're working together with the institute in Switzerland, where the first exoplanet was found. And they're actually setting up a new telescope in Chile, just about now, especially for exoplanet research, and they're very, very interested in working with us. And I think, again, thematically, it's something that fits very well in EVE Online. And then we're working together with a guy who has a project of modeling gravitational lenses. And that's quite interesting because you get an image from Hubble Space Telescope, you start to play with a model, you're setting parameters and things like that, and then the model generates you another image. And if the two images are close to each other, then you have a good chance of having a good model. And then we have that's rather an incubation phase because it's not so easy to integrate. But then we have guys who are in humanitarian crisis help. There are a huge amount of unstructured data in humanitarian crisis situations, and we are just trying to find ways how to help these guys. It would be, I think, you know, I've seen last Fanfest CCP Seagull talking about the Plex for Good initiative, and I think it would be quite amazing if you guys, just by playing EVE Online, could help in a humanitarian crisis situation. And then just about the future, there are projects which are really in incubation phase, where, because these tasks are mainly single-player tasks, but then there are problems in science where to solve the problem you have to work together. So these kind of problems can all be solved with a group of people working together, which I think it's amazing. And finally, I wanted to make my "We need you" speech, because we really do need you, both in the long term and in the short term. I think to make this project a reality, to make it, to get it from a prototype into something that's working in EVE Online, we need your support. So if you find this thing to be something we're supporting, then please don't hesitate to show it. Show it in every forum, tweet about it, blog about it, write about it. Go to the EVE developers and tell them that you like the idea. Also, we are here, the whole Fanfest, so we're happy to talk to you and share your ideas with us and your thoughts. Don't hesitate to grab a beer / coffee with us. We are also going with the CCP Scarpia for the pub crawl, so I think that's going to be a good place to talk. Again, we'll have a roundtable after this one, so if you're interested, please come. And finally, I wanted to introduce you to our new charming CEO. She's Sophie, and she's leading the corporation MMOS. What a surprise. And it's going to be, again, another place where we really hope that we can communicate and talk about the project. So that's it. Thank you very much.
Yes. Hello, everyone. Glad to see so many people. So yeah, thank you, Attila. I'm here basically because I completely fell in love with this idea when I heard it first. I think it's a very, very strong concept, both from the perspective of as a player and also as a game designer. I've tried, I myself tried out participating in citizen science some years ago. I actually ran into Galaxy Zoo, did a lot of these, and it was once you actually start, you churn through a lot of images, and every once in a while you see something really, really, really awesome, and you know that maybe you're the first person to actually see one of those images, maybe, and that's really inspiring to me. And the prospect of gamifying these kinds of images and tasks related to them to Eve seems very clear. So while Eve is a science fiction universe, I also believe that just a lot of you have a genuine interest in and sort of a mature enthusiasm for science in the real world. How many of you saw the eclipse today? Yay! Pretty amazing. But yeah, I mean, so it's not just astrophysics, but also in cosmology and biology, zoology, geology, and all kinds of sort of applied science and cool advanced engineering. This is an incredible. I can't go into it; it's too long. But it's amazing. These are nano, like printed nano structures, injecting DNA into blood cells or something. Incredible. So yeah, like if you're just on Twitter or Reddit, on the Eve Reddit, like people post these all the time. So, but on top of that, I also, like Attila mentioned earlier, the Eve player base on a lot of occasions, not just during the Press for Good, but also going way back, has a lot of occasions at their own initiative sort of asked us to help them, and like, you asked us to help you aid in a humanitarian crisis. So you've like shown a lot of your sort of altruistic nature, and you're good people, and you show interest in it. So it's not really, a stretch of the imagination to think that you too would be interested in something like this and find it compelling. But also just in addition to the obvious sort of intrinsic motivation for us as developer to at least explore this and maybe find something cool to do with it. I just want to make a point that just as a game designer, it's, to get the chance to work with image libraries of like virtually limitless sizes filled with this raw material, this raw, beautiful material that's just by nature completely unpredictable and complex. That's just very inspiring. You have hundreds of thousands or millions of these. It's just, I don't know. I find it very, very, very cool. As you might imagine, there's a huge variance in the types of projects that are bidding for your attention when you're actually participating and you're a citizen scientist. But there's certain qualities and requirements that we've identified that we think make certain projects better than others as candidates for this, for Eve. First, the real-world problems, the real-world purpose of the research needs to be charitable and altruistic in nature, and not controversial by anyone. For example, a research that's meant to help diagnose or cure a disease, or gather and classify knowledge about the cosmos is really, really sort of up our alley, as opposed to analyzing data for self-interest companies or to advance someone's agenda or whatever else. Secondly, the images and the data used needs to be aesthetically fitting for Eve and easily adaptable thematically to the universe. So I could easily imagine any of these work, and plenty of others actually. Whereas like real-world wildlife pictures or and there are other examples of images that it would just be too hard to actually fit or would never actually work. Third, the player tasked to analyze the images and or the data needs to require reasonably consistent length of time, at least within a project. Because we want to sort of we want to make sure that you can build up an expectation for how long it takes, so you can actually get it into your routine for whatever you're doing. If we designed it so you could do it at any point, like you could do it while you're mining or warping or waiting on your fleet to assemble or whatever. Like, for instance, Galaxy Quest and things like that would work really well because for like 99.9% of all the tasks, they all take between like 5 and 10 seconds when you've gotten used to it. Whereas this one, which I also participated in and Attila mentioned earlier, varies a lot. You can find these are otherwise aesthetically fitting, like you're actually mapping out craters and anomalies on the moon surface. Some of the images only have like 1 or 2 craters, and the others have, you know, 100 of them, and take like 10 or 15 minutes if you actually want to be diligent and contribute. Which, yeah. Finally, we think the project needs to require a high volume of tasks to solve. Even though, of course, we would like to build this, if we did this, we would like to build it as a platform where, you know, to be able to contribute, once a research project is done, we want to be able to replace it with something new. We still don't want to do that too frequently, and we would think that this would actually, we would better serve projects that need a lot of tasks, like hopefully in the millions, but at least in the hundreds of thousands, depending on the popularity and activity, obviously. So then the big question is, like, how would it actually be implemented? How would it be designed and implemented into EVE? And the short answer is we just don't know yet. It's not for the lack of ideas or eligible research projects or internal interests. There's plenty of those. We're just not focusing on that question already. We'd love to hear your feedback on it, and we have ideas that we can talk to you about at the roundtable after this. But we're just not focusing on that right now. There's some other open questions first that we want to answer. But just to give you some short examples, just sort of the level of integration we could do. We could go anywhere from, at a very high level, sort of just create a mini game that lets you accrue points, and you can use them for voting in community events, like the Tech 3 Destroyer research race or something, you know, something like that. That's then also just very sort of altruistic in the game. It's not directly connected to your progression, etc. Or we could bring it down another layer and actually make it a game that rewards you with items that can be used as materials in blueprints or research, or it could be integrated as a core mechanic in some solving games in the game, similar to hacking or probe scanning or something of that sort. But yeah, we're not focusing on answering that right now. But ultimately, whether it eventually gets designed and introduced into the game will depend on the following. Basically, the outcome of the prototyping efforts. We're working on the first prototype right now. Maybe we'll work on another one or learn from this one, or maybe this one will turn out great. It's actually looking really cool, and you can actually get your hands on it and see it at the roundtable. The single point of failure here is if there's not interest or enthusiasm about this from the players. There's no reason to put this out, and unless there's at least like basic sort of intrinsic motivation to participate in it, and that people believe that it would actually be good for EVE, then we just wouldn't do it. So please tell us if you are interested in it. And then ultimately, if when those two things have been put together, as soon as an EVE team would pick it up and have a cool, compelling need for the gameplay it can provide, then we would start talking about what it actually would turn into. So to help us answer some of those questions, at least the first one, we're really lucky to have a couple of students from the Reykjavik University. These are the best pictures I have of them, but they're sitting over there. So they're developing a browser prototype to mimic how this could work within EVE. And they have the demo downstairs, like I said. Ta-da! This is the university. The project we picked for this is from the Human Protein Atlas that Attila was talking about earlier, and I just wanted to show even more pictures of it because I think it's beautiful. It's basically a research project for a publicly available database with millions of high-resolution images showing the spatial distribution of protein and human tissue, cancer types and human cell lines, etc. And while each image is completely unique, they all have a very strong sort of common aesthetic. So once we've decided, like, once we found a theme or like explanation for what it is within the universe, it's very easy to see. Like once you've seen one of them, you know exactly where it's coming from. And that's actually common with all of the projects that I've seen. Like they all have a very sort of strong common aesthetic, even if they have like infinite variance within them, which is good for this. I like this one. So we actually have a short video message from the research partner that's working with us on this one. So let's see that before we move on.
Defines who you are. This genetic code contains 20,000 genes that are translated into proteins that make up your cells.
After the human genome was characterized, the next step is to identify all proteins our genes are coding for, and ultimately to understand their function and connection to disease. The Human Protein Atlas is a Swedish research project to perform this task. In total, over 1,000 man-years of work is spent so far to generate over 13 million images showing the spatial distribution of proteins. These images are presented in a publicly available database used by thousands of researchers.
This seemingly massive undertaking pales in comparison to the over 300,000 man-years the world spends each week gaming. In EVE Online, you'll be helping us at the Subcellular Protein Atlas to understand protein function by recognizing patterns of protein localization within colorful fluorescent microscopy images, where specific proteins have been marked with fluorescent labels called antibodies.
These images are extremely rich in information, and we now hope that the gaming community can help us to harvest this information and turn it into biological measures available to researchers all over the world.
I think there's a second part to it as well. Yes.
The human body consists of 100 billion cells, and all cells in the same individual carry identical DNA. So what is it that makes the cells so different? That some cells form the skin barrier and others are involved in signaling in the brain. It is the proteins. Proteins are the essential building blocks of every living cell, and it is the proteins that maintain life and make us who we are. There are around 20,000 different proteins in the human body, and the aim of the Human Protein Atlas is to create a map where in different cells and organs these different proteins can be identified. The results are displayed on the Human Protein Atlas, an online portal divided into 4 different sub-atlases: the Tissue Atlas, the Subcellular Atlas, the Cell Line Atlas, and the Cancer Atlas.
Hi, my name is Cecilia Lindskog and I'm a researcher at Uppsala University in Sweden. I'm a site director of the Tissue as well as the Cancer Atlas, which contains samples from 44 different normal organs as well as the 20 most common types of cancer.
This image is a 1 mm sample from human pancreas, containing several thousands of cells stained in blue. The cells colored in brown are cells producing insulin. These are the cells that are not working properly in individuals with diabetes.
Hi, my name is Anna Asplund and I'm a researcher at Uppsala University in Sweden. I'm heading the Cell Line Atlas, which includes protein data in 44 different cell lines. Cell lines are commonly used as model systems for primarily cancer research.
This is an example image of a lung cancer cell line used in lung cancer research. The antibody detects the protein emerine, which is localized in the nuclear membrane. This is evident as brown color lining the blue nucleus. Protein localization within the cell is manually analyzed, and the Cell Line Atlas contains nearly 500,000 images, and this number is continuously increasing.
The Human Protein Atlas contains more than 13 million images, and manual analysis of the enormous amount of data remains the bottleneck. More detailed description of the proteins would benefit both basic and clinical research. The more help we can get from the community, the sooner we would reach a complete map of all human proteins.
All right, thanks. Okay. We have some UI concept art as well here, just to show you a little bit, if you can't make it to the roundtable, what this will look like. So for the sake of the prototype, since I said we're not focusing on exactly what it's going to be in the game, we're just focusing on completing the task, making sure that it feels correctly aesthetically and sort of fits within the theme of the game. So for the sake of it, the player basically is solving tasks and just accruing points and gaining more rank, and getting feedback for how well he's doing as he goes on. So you see here on the left, you see the sample picture, and on the right on the left is the picture you need to analyze, and on the right you see all the sample pictures that which will have descriptions for basically what you need to be identifying and what and how they map to the picture. Sorry. So you can pick anywhere from one. You can pick one or more of these. So you then you flick through. You get the information and upload a picture of what it looks like. Make your selections, and at the end, when you submit your results, it analyzes it and then gives you feedback there in the upper right corner for how well you did and how many points you've gained. We're also you can also see at the top there other projects that I think we would like to actually get to, but for the prototype today we just have this one. So yeah, if you want to look at it, if you want to try it, if you have feedback, if you want to tell us you love this idea or you hate it, or if you have ideas for how we should use it, etc., please come to the roundtable. It's at 2 o'clock downstairs in Gita, and perhaps at future Fanfest we'll actually be here giving you an annual report of your contribution to the betterment of humankind that you've contributed while making friends and killing them in EVE. So just to close out, thank you all for coming. I have another video message from other research groups that would like to work with us, that they recorded and sent us, and some of them are really fun, and others are really inspirational, or both at the same time. Thank you.
Hi, I'm Francois Gray. I work with the Citizen Cyber Science Center. We're a partnership between CERN, the Particle Physics Lab, the UN Institute of Training and Research, and the University of Geneva. I'm so excited about this project. I have been working on citizen science projects for over a decade now, but never before have I thought that this would be possible to get gamers like you involved in science. Now, a lot of my colleagues in science think that this is all about getting some kind of free workforce to do a lot of work for them, but I see it quite differently. This is about getting you guys involved in real science, doing science, contributing to science, participating in changing the way science is done worldwide. And my dream is that one day I'm going to meet a young EVE Online gamer who's going to tell me, look, I now am a scientist. I went to university because I played EVE Online, got really interested in science, and hey, this has changed my life.
digital humanitarian and the co-founder of the Internet Response League, IRL. For the past 10 years, I've been developing humanitarian technologies to improve relief efforts worldwide. I've had the pleasure of working side by side with international humanitarian organizations like the United Nations and the Red Cross. I've done this both virtually as a digital humanitarian and also on the ground in the aftermath of major disasters. One of the most pressing challenges that humanitarians face today is big data. Flash flood of social media, and satellite imagery, and other data sources that get generated during disasters. Now, traditional humanitarian organizations are completely overwhelmed. This explains why my colleague Peter Moser and I founded the Internet Response League, IRL. We believe that gamers can win the big data battle during disasters. IRL is a growing community of gamers who want to support relief efforts while simultaneously gaming. Gamers can make a real difference. Thanks to CCP's Plex for Good initiative, for example, gamers have already raised hundreds of thousands of dollars for victims of devastating earthquakes, hurricanes, and other hazards over the years. And now we can do even more. We can partner directly with humanitarian organizations and help them win the big data battle simply by playing EVE Online. Sound far-fetched? Think again. Thanks to our collaboration with MMOS and EVE Online, we're investigating ways to convert humanitarian efforts into gameplay in a way that you won't even realize you're being a digital humanitarian. We want to create an incredible experience that you'll find intriguing and very captivating. MMOs exist largely for entertainment today, but we believe they can save the future of the planet. Thanks to our cooperation with MMOs and EVE Online, the day you can become a digital humanitarian may come sooner than you think. As next generation digital humanitarians, you'll have the option of making a real difference while playing. Now imagine all the powers you'll gain, both in-game and IRL, from being a real-life gaming hero.
Hi, my name is Pierre. I am an astronomer here in the Geneva Observatory, and I had the very good luck to work with Michel Mayor, the Swiss astronomer who discovered the first planet outside our solar system. 20 years later, planetology became a very important field of astronomy, and we are now building new facilities to observe, to try to find new planets. We have already discovered more or less 1,800 planets, and we are looking for more planets. But we have a big problem now. We are overwhelmed by data. We have data, and with our new facility in Chile, which name is NGTS, we'll have a million of very big data. We are observing more or less 1 million stars every 10 minutes. With this new facility in GTS, we are looking for small planets. Planets like Neptune, or maybe like our own Earth. Imagine you are flying with your spacecraft in our galaxy, and suddenly you are in front of a planet, an unknown planet. How big is this planet? What's the temperature of this planet? What's the duration of a year? If this planet, is it alone around these stars? This is all these questions you can answer studying, analyzing these light curves we can give you. Playing EVE Online, you can make progress to astronomy, and who knows, maybe discover a planet like ours, the Earth. C'est très difficile pour moi.
Hi, I'm Yvan Lebras. Originally, I'm a marine biologist, but for now, I'm working on an exciting project to develop e-science approach in Western France. This project is supported by Biogen West, a network who coordinates 31 technological core facilities and federates 70 research units involved in marine resources, agri-food, health, and bioinformatics areas. One big part of the project concerns the analysis of huge amount of data. Are you ready to play my data?
So here we start a part of the knowledge of life sciences research units in Western France. You can find the data and metadata building our data infrastructure. And now we are ready to plug into Eve. Are you ready to play with it?